Hi, I'm Miss Roger, and welcome back to Core Concept in Algebra 2. Today's lesson is on solving systems of linear inequalities. The Massachusetts curriculum frameworks for mathematics are specifically tied to this lesson. A-REI, reasoning with equations and inequalities, number 3 and number 11, and A-CED, creating equations, number 2 and number 3. Today's lesson objectives are to solve systems of linear inequalities graphically and to identify the solution where constraints are both satisfied. For the first problem, we're going to graph two linear inequalities. Once we have both inequalities graphed, we're going to figure out where the solution is. The solution is typically where both inequalities overlap, and that's going to be where both constraints are satisfied. So if I graph the first inequality, I have a y-intercept of -2. So I plot my first point at -2, and I have a slope of -5. So I'm going to go down 5, 1, 2, 3. That's going to be off my graph. So I can think about -5 as 5 over -1. So I'm going to go up 5 in the positive direction, 1, 2, 3, 4, 5, and over 1 in the negative direction. Now I can build my line. There's a couple things that we want to consider before I draw my line. When I have a greater than symbol or a less than symbol, I'm going to have a dashed line. When I have a greater than or equal to symbol and a less than or equal to symbol, I'm going to have a solid line. So for the first inequality, you can clearly tell that I'm going to have a solid line. Let's graph the first inequality. We need to now determine which direction to shade. We're going to either shade to this direction or we're going to shade that direction. One way to do this is to test a point. I like to test 0, 0. However, for this problem, it seems really close. So I can test any point in this region and any point in this region and see if it makes the statement true or false. I'm going to test 1, 1. That's my test point. So I'm going to substitute 1 in for x and 1 in for y and see if it makes the inequality true or false. One is greater than or equal to -7. This statement is true. Because the statement is true, I know that this region will satisfy my inequality. So you can almost think about it as if it's covering up the point that you tested. Let's graph the second inequality. We have a y-intercept of 1, a slope of -1, and a solid line. Again, we're going to test a point. Either a point in this region or a point in that region. We're going to see where the blue and the red overlap. That's going to be our solution. Let's test 0, 0. Zero is greater than or equal to 2. That statement is false. That indicates to me that this region below the line does not satisfy the inequality. So I know I have to shade in this direction. My solution is going to be where the blue and the red overlap. Specifically, it is going to be this region. This is my solution set. Let's take a look at the next problem. We have two linear inequalities. We're going to graph both and see what the solution set is. So for the first one, we'll do this one in blue. We have a y-intercept of 2 and a slope of -1/3. So I'm going to go down 1 and over 3 and up 1 and over 3 in that direction. Notice we're going to have a dashed line for this problem. Let's test a point. Let's test 0, 0. So if we substitute 0 in for this problem, we're going to get a statement 0 is greater than 2, which is false. That's going to indicate that we're not going to shade below the line. We're going to shade in the other direction, above the line. If I were to test a point in this region, I would get a true statement. Let's graph the second equation in red. This problem is also dashed. I now need to test a point to determine if I'm going to shade up or down, above or below the line. Let's try 0, 0. For this, when we plug in 0, 0 to our second inequality, we get 0 is greater than -1. This is a true statement. That's going to indicate that we include the point when we determine which direction we are shading. Now, to figure out our solution to this system of linear inequalities, we want to figure out where the blue and the red overlap. If you have colored pencils, it might be best to try and use them on these problems. This region right here is our solution set, what's highlighted in yellow. Let's take a look at another type of linear inequality systems problem. Y is greater than x minus 2 and y is greater than x plus 2. Wow, these two lines are going to be parallel. The way that I know that is because the slopes are the same. Both slopes are 1. Let's see what's going to happen. Let's graph our first inequality in blue. Y-intercept of -2 and a slope of 1. It's always important to build multiple points on your graph and use a ruler. Notice we have two dashed lines. Let's test a point. I'm going going to test 0, 0 to determine if I'm going to shade below the line or above the line. When we substitute the ordered pair 0, 0 into the first inequality, we get 0 is greater than -2. This is a true statement. So we're going to include the point 0, 0 when we shade, and this indicates that this is the solution area for this inequality. Let's graph the second inequality. Y-intercept of 2 and a slope of 1. These two lines are parallel. Let's test a point. I'm going to test 0, 0 again. When I test the ordered pair 0, 0 into my second inequality, and I substitute 0 in for x and 0 in for y, I get a false statement. 0 is not greater than 2, which is going to mean that this ordered pair in this region is not the solution set to my inequality. So I shade in the opposite direction. When looking at the graph, the solution area that satisfies both constraints is where the blue and the red overlap. For this problem, it's going to be this region. For our last system of linear inequalities problems, let's take a look at number 4. Notice that both of these equations are not in slope-intercept form. Slope-intercept form is y equals mx plus b. If we're graphing and solving a system graphically, we need to put both of these equations into y equals mx plus b form before we graph. So let's do that. This is the inequality for 3x plus 2y is less than or equal to 4 in slope-intercept form. When we have inequality signs and we are dividing, there's one rule that we want to remember and consider. When we multiply or divide by a negative number, we have to flip the direction of the inequality sign. We did not see it on this problem, but we may need to use that fact for the next problem. Notice on this inequality, when we divided by -1, the direction of the inequality sign flipped. It went from less than to greater than. This is important to consider when dealing with inequalities. Let's graph both and see what the solution set's going to be. I'm going to use both of these equations to graph. For the first one, I have a solid line. Let's test a point. When you test a point, you can either use the two equations that you manipulated or one of the originals. I suggest using one of the originals in case you made a mistake manipulating. You may find it when doing that. Let's test 0, 0. When we substitute 0, 0 into the first inequality, we get a statement 0 is less than or equal to 4. This is true. So we're going to shade in the direction where the ordered pair 0, 0 is. Let's graph x minus y is less than 3. Y-intercept of -3 and a slope of 1. Let's test a point. Let's test 0, 0 again into the original. When we test 0, 0 in, we get 0 is less than 3. This is a true statement. The solution to this system of linear inequalities is the area where we have overlap. We have two inequalities which both constraints must be satisfied to be the solution to both inequalities. In this case, our solution is going to be this region. How can a system of linear inequalities be solved graphically? What is the solution to a system of linear inequalities? And what type of real-world problems can be solved using systems of linear inequalities? Think about these problems tonight, and we'll discuss them more tomorrow. After watching me solve these problems, try these. Sketch the solutions to each system of inequalities for these 4 problems. Remember to use a ruler and graph paper, and if you have colored pencils, that would be really helpful. Thanks for joining me, and I'll see you tomorrow.